हेलो एवरीवन, माय नेम इज निखिल सर. आप सपोर्ट क्लासेस हातुरे हुडगी रोड शोलापुर. We have started 9th chapter in science of class 9 NCERT, that is force and laws of motion. In that we have studied some part of this chapter in our previous videos. Those students who have not seen those videos, please go through those videos. I have provided you links of those videos in my description box. You can check my description box and please see those videos. Now we will move towards the next part in this chapter, that is third law of motion. Please don't put your textbook in front of you while watching this video and be ready with your pen, pencil and notebook. The first two laws of motion tell us how an applied force changes the motion and provide us with a method of determining the force. We have studied previous two laws of Newton. In that we have studied an applied force changes the motion and provide us with a method of determining the force, means calculating the force. The third law of motion states that when one object exerts an force on another object, the second object simultaneously exerts a force back on the first. In the third law of motion state that when we exert a force from one object to another, that time force goes on the second object simultaneously, and that second object gives a force back on the first. These two forces are always equal in magnitude but opposite in direction. But those forces are equal in magnitude but opposite in direction. These forces act on different objects and never on the same object. Means this force act on different object and never on the same object. In the game of football, sometimes we, while looking at the football and trying to kick it with a greater force, collide with a player of the opposite. If we see the example in the game of football, sometimes we are looking at the football and trying to kick it with a greater force. That time collide with an player of the opposite team. Both feel hurt because each applies a force to the other, and in this situation both feel hurt because each force, whatever that force is applied to the other. In other words, there is a pair of forces and not just one force. Means there is a pair of forces, not just one force. The two opposing forces are always known as action and reaction forces, and these two forces we also known as action and reaction forces. Let us see one another example. Let us consider two spring balances. Now I will show you one video. In that video the same experiment has shown you. Please listen that video, and that video is also available on YouTube.
Newton's third law of motion. Sir Isaac Newton was a 17th century English physicist who discovered three laws of motion. Newton's third law of motion states that for every action there is an equal and opposite reaction. In other words, if object A exerts a force on object B, then object B also exerts an equal force on object A. Notice that if the forces are exerted on different objects, they will not cancel each other. The third law can be used to explain rocket propulsion and the recoiling of the gun. Here are some daily life situations to illustrate Newton's third law of motion. When we walk on the ground, our foot pushes against the ground backward, that's action in turn exerts a force on the foot, that's reaction force, pushing the foot forward. When a man jumps from a diving board, he pushes the board, which is action force, and the board in turn pushes the man forward in the opposite direction, which is reaction force. Birds, while flying, push the air downwards with the help of their wings, which is action force, and the air in turn exerts a force on the bird in the upward direction, that is reaction force. Here is an experiment which proves Newton's third law of motion. Materials required: 2 spring balances of different least count, an iron stand fixed on a table. Procedure: arrange the stand. Take 1 spring balance. Note the least count of the spring balance. 5 divisions is equal to 0.25 n. That is, 1 division is equal to 0.25 divided by 5 is equal to 0.05 n. Fix 1 spring balance to the stand. Now, take the second spring balance and attach it to the end of the first spring balance. Pull the second spring balance away from the stand. As you pull the spring balance, you will feel that the spring balance is being pulled back. Both the spring balances will show the same force. Repeat the process. The 2 spring balances will continue to show the same forces. Tabulate all the readings. So we can conclude that when the second spring balance exerted a force on the first, which was the action force, the first spring balance also exerted an equal and opposite force on the second, which was the reaction force. Action and reaction forces are equal in magnitude but opposite in direction. Action and reaction forces act on 2 different bodies at the same time, so they do not cancel each other. Hence, Newton's third law of motion is verified.
I hope you understood it better. Now we will move towards on next part of the topic. The same experiment is there, that is, let us consider 2 spring balances connecting together as shown in figure, that is 9.10. See here in 9.10 the experiment figure has shown 9.10 action and reaction forces are equal opposite. Now the fixed end of a balance P is attached with a rigid support like a wall. See here we have attached, that is a balance B to the wall. When a force is applied through the free end of the spring, balance A, means we have to give the force from this side. This is a free side. Here see, one hand has given and this hand applying a force on the this balance, on balance A. Next we will see, it is observed that both the spring balances show the same reading on the scales, and both the spring balances show the same reading. It means that the free exerted by spring balance A on balance B is equal but opposite in direction to the force exerted by the balance B on balance A. Here we have given force on A and its opposite force is going on B. Any of these 2 forces can be called as action and the other as reaction. This gives us an alternative statement of the third law of motion, and this gives us an alternative statement for the third law of motion, and that statement is every action there is an equal and opposite direction, and this is the third law of motion. However, it is Suppose you are standing at rest and intend to start walking on a road. You must accelerate, and this requires a force accordance with the second law of motion. Now suppose you are standing at rest and intend to start walking on a road. We have seen in previous video this concept. You must accelerate, and this required a force. Means while walking we must accelerate, and this requires a force in accordance with the second law of motion. Now question is that which is this force? This is muscular force. Yes, it is it the muscular effort you exert on the road? This is the second question. Is it the muscular effort you exert on the road? Yes. The next question, is it in the direction we intend to move? Next, no. You push the road below backwards. Means no. There is a no in the direction we intend to move. Means we push the road below backwards. The road exerts an equal and opposite force on your feet to make you move forward. Now on the next paragraph we will move. In the next paragraph we will see it is important to note that even though the action and reaction forces are always equal in magnitude. Means we have noted that action and reaction forces are always equal in magnitude. These forces may not produce accelerations of equal magnitude, and these forces may not produce any acceleration of equal magnitude. This is because each force acts on a different object that may have a different mass, and because of each force act on a different objects that may have a different masses. Because of their different masses they act different forces, same forces on different objects. Now one example has given, when a gun is fired it exerts an equal and opposite force on the gun. Now we will see that via video. Please student check that video. On that video I think you are understood that concept better. See, action force and reaction force. It must be remembered that action and reaction always different objects. These two forces are always equal in magnitude but opposite in direction. I hope you understood better. Now we will move towards on next. Means when a gun is fired, it exerts a forward force on the bullet. The bullet exerts an equal and opposite force on the gun. We have seen that. This results in the recoil of the gun, that is in figure. See here, accelerating force on the bullet is front, and on behind a recoil force on the gun here. Since the since the gun has a much greater mass than the bullet, gun has a much greater mass than the bullet, the acceleration of the gun is much less than the acceleration of the bullet. Because of a greater mass of a gun than bullet, the acceleration of the gun is much less than the acceleration of the bullet. The third law of motion can be illustrated when a sailor jumps out of a rowing boat. I think you have seen the rowing boat. As the sailor jumps forward, the force on the boat moves it backward. See here in the figure. Now we will move towards on next page. See in this picture, sailor is jumping forward and the force on the boat gives the boat towards backward side. Now one activity is there, that is activity 9.4. We will read that activity. Number 1. Request two children to stand on two separate cars as shown in figure 9.13. Give them a bag of full sand or some other heavy objects in the bag. Ask them to play a game of catch with the bag. Third, does each of them experience an instantaneous force as a result of throwing the sandbag? This question has asked. Let's see what next has given. You can paint a white line on cart wheels to observe the motion of the two cars when the children throw the bag towards each other. See here the answer. In the answer, see, when one of the child throws the sack, means action is there, and the other one catch it, they will move backward in accordance to the reaction. What is action? One children throw that sack towards other, and that other student catch it and it goes backward side. This is a reaction. This is explained with the help of Newton's third law of motion, which states that every action has an equal and opposite reaction. Now we will move towards on the next part in this chapter. Now place two children on one card and one on another card. The second law of motion can be seen as this arrangement would show different acceleration for the same force. And then we can see the card shown in this activity can be constructed by using a 2 mm or 18 mm thick plywood board of about 50 cm and 100 cm with two pairs of hard ball bearing wheels. Then skate wheels are good to use. Skateboards are not an effective because it is difficult to maintain straight line motion. Means just they have given how to do this activity. Next part we will see in next video. If you have any queries, any difficulties, you can ask. Please student forward this video to other student or relatives or neighbors and your colleagues, and show your thumb to the video. Thank you.